Setting up the meter start by examining your digital multimeter's dial, which has various symbols printed around it. Find the diode symbol, an arrow pointing at a vertical line, often grouped near the continuity, sound wave icon. Turn the dial until it clicks into place on that symbol. Activating diode test mode. Before touching any probes to your diode, make sure it's fully disconnected from power, and if it's on a circuit board, ensure the board is off with capacitors discharged. Plug the black lead into the COM socket and the red lead into the volts, ohms, milliamps, ampere socket. The display should show OL or a blinking number, confirming the meter is ready. Why this test works: a diode only conducts current once it receives enough forward voltage, roughly 0.11 volts as a bare minimum threshold, though a healthy silicon diode typically shows a drop closer to 0.7 volts once conducting. Your multimeter's diode mode outputs a small test voltage, usually between 2 and 3 volts, while limiting current to a safe level around 1 milliamp. This ensures the diode switches on fully so the meter can measure the exact voltage lost across it. Expect readings around 0.6 to 0.8 volts for standard silicon diodes or 0.2 to 0.4 volts for Schottky diodes. Never test diodes using resistance or voltage settings instead. Testing forward bias, identify the diode's cathode marked by a stripe or band, and it's unmarked anode. Touch the red probe to the anode and the black probe to the cathode, allowing current to flow the easy direction. Within seconds, the display should show a stable voltage reading, ideally between 0.6 and 0.8 volts for silicon diodes. Avoid touching the metal probe tips with your fingers, since body resistance can skew results. Make sure the diode is isolated from other components to prevent misleading parallel path readings. If you accidentally swap the probes, you'll get a reverse bias reading instead, so always verify the stripe first. Testing reverse bias. Now reverse the probes. Place black on the anode and red on the cathode, pushing current against the diode's blocking direction. A healthy diode should show OL, indicating it's successfully blocking current with essentially infinite resistance. Hold the probe steady for a few seconds to confirm the reading doesn't flicker or show any voltage. Any numerical reading at all suggests the diode is leaky or damaged. Don't let the probes touch each other during this test, as that creates a short circuit showing near 0 volts. If unsure whether your meter is working correctly, touch the probes together separately to confirm a near 0 reading. Interpreting the results, a good diode shows roughly 0.6 to 0.8 volts forward NOL. In reverse, a reading near 0.0 to 0.1 volts forward suggests an internal short, meaning the diode conducts both directions like plain wire. An abnormally high forward reading, or OL, forward means the diode is open and won't conduct at all. Any voltage appearing during the reverse test indicates a leaky diode that's lost its blocking ability. Always check both directions as a matched pair before judging the component. If results seem borderline, replace the meter's battery or clean the diode's leads, since oxidation can distort readings. When in doubt, simply replace the diode.